Okay, I'll be explaining question number 3 of your topical revision, a topic on complex numbers. Okay, this question is rather interesting as it's quite different and there's a variety of skills that get activated in this question. Okay, so let's analyze the question first. What you have is you're given a complex number W and you have this equation that your W is supposed to satisfy, and you have this inequality that your W is satisfying. So part 1 asks you to find W in the form of x plus iy. So what you need to understand is that the only equation probably that you can work with is only this equation number 1. So I need to operate on that, and the hint given to you is you need to let W be x plus iy. Okay, so if I let W equals to x plus iy, what is going to happen is that W is x plus iy. W conjugate will be x minus iy. You're going to put all this information into your first equation, and thereafter you're going to get one massive equation that involves x and y concurrently. So your job is to do what you learned in your chapter 1 of a complex number: regroup all the real parts together and all the imaginary parts together. So in order to do that, you better make sure that your basic skills on the manipulation, plus, minus, subtract, division, multiplication of the complex numbers is proficient. So regrouping all the imaginary part and the real parts, you again generate two separate equations. So from this equation, you can actually solve for x to be 2 root 3. Putting this into your other equation, you can actually find the value for y. And from here, you can get two values for y. Y is equals to 2 or y is equals to 6. Then, that's when the inequality comes in. They tell you that the imaginary part of W must be smaller than 5, and that is when you decide that you can only accept y to be 2 because y must be smaller than 5. So you have found the Cartesian form of W. That's the first part done. Okay, and this is absolutely critical, because if you get this part wrong, your part 2, 3, 4, 5, everything that follows will be implicated. And so part 2 is quite standard. You have seen this before in your tutorial, you have seen this before in your lecture notes. Your condition here is that Wn is supposed to be real, and you need to find integer values for n such that W to the power of n is supposed to be real. So what you have now is W in Cartesian form. If I want to raise this to power n, it's going to involve binomial expansion, which is ridiculous. So the trick now is to convert this W in Cartesian form into your REI theta form. Okay, I say again, the trick here is to convert your W, which is in Cartesian form, into your REI theta form. So you need to find its modulus, you need to find its magnitude, modulus and argument. Okay, finding the modulus and argument of your complex number W will leave you with 4e pi over 6i. Thereafter, based on your properties of your indices, rules of indices, UW raised to the power of n is the same as raising to the power of n for 4e pi over 6. Rules of indices tells you that it becomes 4 power n e n pi over 6i. Then, what you need to do now is switch this into your trigo form. Cos n pi over 6 plus I sin n pi over 6. Why I want to switch to this is because it's easier to see. Your condition is that Wn must be real. So if this must be real, that means the imaginary part must be 0. And if the imaginary part is supposed to be 0, sin n pi over 6 must be equals to 0. So the condition is I must make this thing 0. So how can that happen? So if you understand the basics, is that, or your trigo skills is that sine 0, sine pi, sine 2 pi, 3 pi, etc, 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 or even minus pi, minus 2 pi, etc, etc. Sine of all these values will surely be equals to 0. So your n pi over 6 must be equals to k pi, where k is supposed to be any integer, regardless positive or negative. I say again, it's an integer. That means I can take 1, 2, 3, 4, 5, 6, 0, -1, -2, -3, etc., etc. So from here, you shift around, you can show me that, or you can find that n is equal to 6k, where k is any integer. So that is the part 2 of the question. Part 3, question expands some more. You need to find the expansion of this, or the results of this expansion. So what you have is w over 4 power 3, w over 4 power 6. So from here you need to realize that this actually is a GP. First term is 1. Common ratio is w4 to the power of 3. And you need to find for me the sum of this. How many terms are there altogether? You actually can do a quick counting on your own. Okay, if you really cannot, just count with your fingers. You can actually deduce the number of terms. So activate the sum of GP. Okay, and actually there are 8 terms. Okay, so sum of GP formula is A Rn minus 1 R minus 1. So A is just 1. R is W4 power 3. N is 8 minus 1 divided by R minus 1. So simplifying this, again what's happening next is that when you hit here, your rules of indices come in again. You have E 4 pi I minus 1 over I minus 1. So what is actually E 4 pi I? If you actually work it out, is 0. So, sorry, it's 1. Okay, and then everything will simplify just straight to 0. So that's your part 3 done. Next, okay, question gives you more condition. You have a complex number z, and then this complex number z has modulus 4, and this complex number z satisfies this so-called equation. So again, you're supposed to find z in the form of a plus bi. So again, this is something new. So in order to handle things like this, you need to activate your properties of argument. So on the left hand side here, argument zi over 1 plus I, activating your properties, it actually becomes argument z plus argument I minus argument 1 plus I. Okay, and from here I can actually find argument of I is pi over 2. Argument of 1 plus I is actually pi over 4. So this equation was so-called simplified into argument z plus pi over 2 minus pi over 4 equals 3 pi over 4. Readjusting everything, you're left with argument z is equal to pi over 2. Then, going back to the question, you should have realized that they already tell you the modulus of z is 4. You have found the argument of z. So you have all the criteria necessary to write down actually what is your complex number. So since argument z is pi over 2, modulus of z equals to 4, your complex number is actually just 4e pi over 2i, which actually simplifies to 4i straight away. Okay, next part. Thereafter, okay, they give you some geometry things to take care of. You need to find the area of triangle ZWO, where Z and W are the points on an Argand diagram that represent Z and W. So this one again hinges on your ability to find Z and W previously. If previous answers are wrong, confirm this part will be wrong. So we have found what is Z. Z is just 4i. We have found what is W. W is just your 2 root 3 plus 2i. What you need to do now is display this on an Argand diagram. So if you actually were to display this on an Argand diagram, something like that will happen. Okay, draw it on an Argand diagram. This is where W is. This is where Z is. You're supposed to find the area of this triangle. Okay, so area of triangle, nothing really fantastic. It's half base times height, or half AB sine theta. So looking at this, do you know what's the base? This is the base. This is the height. Okay, and the height is just the distance from origin down to here, which actually is your x coordinate. So it's half base times height. You get the area directly. This method is much easier and easier for you guys to digest.